Okay, let's look at isotopes. And what are isotopes and how do isotopes control or influence the average atomic mass of an element? Okay, so let's first define what is an isotope. An isotope is an atom of an element that has the same number of protons but a different number of neutrons, meaning that its mass number will be different. Because remember from early in chemistry, mass number of an element is equal to the protons plus neutrons. Okay, so mass number is equal to the protons plus the neutrons. Okay, and I've got the little plus sign up here to remind you they're positive, and the 0 for no charge on a neutron. Okay, so when we look at the periodic table for neon here, when we look at that, you see, always two numbers on the periodic table for each element. You see, the symbol Ne, and then you see its atomic number is usually on the top in the box on the periodic table, so 10 here. And then below it you see a number that's often referred to as the mass number, and that mass number always seems to have a decimal of some sort. So on the periodic table I'm referencing, they have neon as 20.1797. Now your decimal may differ depending on the periodic table you're looking at. Some do 2 decimal places, some do 3 or 4. Just whichever periodic table you're looking at, you will see some difference. Okay, so when we look at neon, neon is actually not just one single atom. It is a mixture of 3 different isotopes. Now those isotopes, you've got one that's the heaviest, neon 22 isotope, has 10 protons, 12 neutrons for a mass number of 22. We find that in nature just a little over 9% of all neon happens to be the neon 22 isotope. Then there's a second isotope that's the 21 isotope with 10 protons, 11 neutrons, and only about 1/4%. And then the overwhelming majority of all neon atoms is the neon 20 isotope with 10 protons and 10 neutrons. You can see it's almost 90.5% of all neon is that particular isotope. Okay? Now, when we look at the periodic table, where does this 20.1797 come from? It comes from an average of the 3 isotopes, but it's not a simple average of 20 plus 21 plus 22 and then divided by 3. It is an average based on the mass and the abundance. So the average atomic mass. Okay. So the mass number you see on a periodic table is equal to the sum of these 3 isotopes based on and their abundance. Okay, so to calculate that, it looks like this. You take the mass number of each one, so 20 for this first one, and you multiply it by the percent abundance. Okay, now this percent abundance, I am changing it back to decimal form. Notice I'm putting 0.9048. And then you add to that the second isotope with the mass of 21, an abundance of 0.0027. Now notice I changed that back to decimal form. So I'm moving the decimal 2 places to the left, and then plus the third isotope with a 22 mass, and the abundance, I change it back, is 0.0925. Okay. When I solve this right here, this equation, this will give me the average atomic mass. This will give me the mass number from the periodic table. Okay? So all of the isotopes present for an element are found in different percentages, how common they are. you take those percentages, take the mass, and you do an average based on that, and you get what we call the mass number or the molar mass of an element from the periodic table. One side note about isotopes. Isotopes, some are radioactive. They're the ones who display the radioactivity properties that you see. For example, one of the most common radioactive isotopes is that of carbon, and it's carbon isotope with a mass number of 14, meaning it has 6 protons and 8 neutrons. Okay, this isotope is used in dating of artifacts, like whenever they find Egyptian or mummy artifacts, or an anthropologist or an archaeologist finds some sort of fossil, some sort of artifact from a dynasty or a kingdom in Rome or Greece, and they want to date it. They will date it by looking at the abundance, the presence of the carbon-14 isotope, that radioactive isotope. Okay, so when you see a molar mass, a mass number for an element on the periodic table, okay, so I'll put my periodic table over here. When you see all these mass numbers on the periodic table and they're sitting in decimal form, that is an average atomic mass based on the mass of the isotopes and how naturally abundant they are.